So we're going to learn equations. And I think the most canonical example of where to apply equations is with this. I'm sure you've used screws and bolts and nuts in the past. And like, if you design one of them, you can design all of them. Right? Would you believe me if I said that?
Yes.
Say you had like the base design of this model right here. So you have the length of this thing, and maybe you know the hexagon is supposed to be this big, and then you know the pitch between the different, right? Like that should be enough. And that's what we're gonna try to do right now. We're gonna start by making first a model of a screw, and then we're gonna create some parameters to see right what does the screw depend on. And then I'm not gonna let you try it yet, because what I'm gonna let you try instead is this, which I think is a little more interesting. Let me actually open it in a new tab. Oh, it's a tiny chair, but you can at least see the picture. It's not too difficult.
Yeah.
In fact, looking at it, how would you do it?
Oh, I would start with the base, and it looks like you can, if you did like a 2D sketch of like straight and then a leg, you could try and like revolve it around. Or like to make the round leg, you could use what's it called? Like where you project it along a line.
Like the project geometry command.
No, it's like tracing the line.
Sweep.
Yeah, sweep.
Yes.
That's what it is. You could use sweep for the weirdly curved legs.
Like yes.
And then like rotate it around, do 5 of them.
Yes.
And then for the top part, well, you got like a circle extrude, and then you have that, and then you could do. How would you make that?
All of what you said so far is correct. I'll show you another, but I think that's good. Like it's more like that one. I would just do a circle and then just slightly more, and then I would do a cut through the top.
Yeah.
And then that's how you're gonna generate that shape. Doesn't look too bad, and we can make a pretty realistic one. And then, time permitting, I think we will have enough time. We will make this. Well, actually, yes, this looks like a mess right now. Let me just. This is complicated. We're not gonna get to this level of detail, but we'll make actually something that looks pretty similar to an airplane fuselage. It's not gonna be too difficult actually, but the whole point with both the chair and the screw in here, let me just open a picture, is that once you make a singular model and you just maybe we can spend 10-20 minutes making it well defined in every single dimension, all of the different properties. Then if you use the equations, changing things like the width, whether this is a narrow body or a wide body, or the number of windows or the number of exits, it's gonna be super easy.
All right.
I think so. So let's start with this. I'm gonna go to Inventor. So let's do, this one is gonna be quick. This one is for your personal enrichment.
Right.
But the chair, I'll let you do it. Unless you want to try that. This one you can just watch. It's just more like illustrative.
Yeah.
This is more for you, the YouTube people. Let me speaking into the camera. So we'll go here to sketch. And I'm gonna go here. And I'm gonna start by drawing a line. We're gonna learn a new command today that's called coil. Because you'll need it, right, to make the. So as always, don't worry about dimensions. As we know, we can use the scale command, which we learned last time with there. But I do worry about the general proportions, though. So we're gonna make a screw. Wait. Just Control Z. So I'm just making like the body in the sense that we're gonna revolve that. Right? So you can imagine this is the axis of our screw. And there's a why we're doing it in this particular way. I'll explain in a moment. Is because that's what will allow us to use the coil command. So I'll keep it simple by drawing a circle. So this is it's gonna be a very special type of screw. So I'll make it say 0.1. That instead of a circle, you could make it into, could be like a sharp edge.
Yeah.
In fact, actually, you know what?
Oh, that's gonna be the thread.
That's gonna be the thread. No, we're better than this. We can do that. So I'm gonna make something like that. So we're gonna assume that the size of the thread is always gonna be the same. So let's make that 0.08, and we can define this dimension here to be 0.02. Wait. Oh, well, okay. Inventor wants me to define that dimension first. I could also click in these two lines and make them equal if it's complaining too much. Okay, so we're gonna leave like this, and I'm gonna click on finish. Now, what we can do is go here to our friend the revolve, and we'll select this area and that axis. I'll say okay. Now everything disappears, so probably we will have to bring this sketch in here, visibility. And then what we're gonna do is I'm gonna create an axis in here. And now what we're gonna do is this command that's called coil. So for coil, it will ask us for a profile. So I'll say, actually, what I might need to do is, let me create a new sketch on that plane. And what I'll do is here at project geometry, these three guys. And let me, there we go. So if I click on finish, and now I hide that sketch, that should appear there. Okay, so we're just gonna create the threads of this coil. We go here to coil, then so profile, it identifies that. For axis, we're gonna say that guy. So you see how it creates a coil. Now, what can we define? Well, one of the properties is the pitch. So you can do, there's the whole field coil, like just threading in general. Like 0.2, and that revolutions, we can say, actually, it doesn't matter, like revolutions, we can do like 12, it's okay. Oh, and I do not, sorry, there was a mistake of mine in there. I do not want to, there we go, I want to go for that one. Ta-da! Now, the only problem about this is that, actually, let me go edit, no, not edit that sketch, but edit the call property. Is that if I do 12 and 0.2, we have to make the math such that this will end up being like there. So maybe let me leave it at 10. Okay, that's fine. Screw. And what we can do is now a sketch in here, and we can go to our friend the polygon, and this time it is a hexagon. So we can, for instance, say that you want that distance to be, actually, one thing that I should do is, there we go. Just make that parallel, and we can define the diameter to be 0.6. And then we bring this up by good. You are now a screw engineer. As I always say, if your career fails, you can make Lego bricks, you can make like boats, cars, toys, screws. Just because of fun, like I'm gonna look at these edges, and I'm gonna slightly fillet them. Now, suppose your boss comes, because this will always happen in life, and the boss goes, "Hey, great job, but I need 20 different versions of this screw." Would you go for? You have two alternatives. Route A is, do I save us 20 versions of the screw and I modify them in one of those? Or route B, I create equations. Which one do you opt for?
I can't imagine how the equations would work.
Thank you for bringing that up, because let me show you. So the way you do is you go here to, there's this little FX command in there. So let me click. And what you can see in FX is that little guy in here consists of all of those different sketches, properties, even the colors. It's all encapsulated there. It's difficult to see what they all correspond to, but we can create parameters that you could say, right, I want the height of this to be 20, and that's going to be parameter A. I can reference that as parameter A right there. How do you do that? Well, I'm going to go here where it says add numeric, and I'm going to create the user parameter. And what can we modify? Let's say the height is one of them. Let's make the height 5. Oh, 5, there we go. Let's just make this a little bit bigger. What can we do? Let's do head dia. By the way, oh, you know why that is an error? Because we need to do a little underscore. Otherwise, it's not complaint. Yes, we can do that. So we said that was 0.6. Say 0.8 as an example, right? Now we could do another one. Let's do a coil. There. That's gonna be like that diameter in there. Oh, edit. See the same issue as before. And we can make that one 0.3. And let's click on done. I haven't done anything. I just created those parameters. What we can now do is go here back to our original revolution, edit that sketch, and say, well, instead of 0.3, I'm gonna go here and we're gonna call that one coil. Yeah. And see how it was red, now it's black. And if I click on save, it goes to FX coil. Yeah. Well, don't thank me yet, because this is not, we haven't done much yet. We're gonna call that one height. It's automatically adjusting, and now
It's adjusting to the numbers
that we put earlier.
Look.
And now I'm gonna click on finish, and obviously we have to now go back to our friend the coil, edit feature. And we're gonna say, oh, actually, I'm gonna click on OK for now. Hello. I'm gonna go back to equations, and I'm gonna create another parameter that's gonna be called pitch. And for pitch, we can make that one be 0.2. Let's click on that. Why this? Because we go to coil, edit feature. So now we can make that one pitch. And then for revolution, let's make this height over pitch. Right? But you have the height and the picture that tells you how many times you would have to replicate that stuff. Let's go to OK. Ta-da! And one last thing. Let's edit this sketch. Let's make that one. Well, that 0.6, let me delete it. We said this was diameter, right? So this was what, like head dia, was it called? Yes. Okay, 0.8. And we click on finish. Good. First thing I'm gonna do is I'm gonna save this, because it's always a good practice to save. So let's call it screw. I go there to save. However, let's do the magic. Let's go back here. Tell me your favorite combination of 4 numbers. Or just give me some random numbers in here.
2,
2,
0.5,
0.5,
0.2.
0.2. By the way, I'm realizing that I might need to change that one later, right? And then for this one,
0.4.
0.4. Okay, interesting. Update. Woo! Now I got a screw. Again, now I'm realizing that I'm gonna go back to this sketch. This one we called it the dia, but it's the radius technically. So I'm gonna divide that one by 2. There we go. Interesting looking screw, but it's technically fully defined by those 4 parameters right there. And just because
These things it's very cool.
let me make this chrome, because why not? And now you got a chrome looking. Perhaps the only thing that we could do is also like modify like the head height if you wanted to, or something like that.
Do I like replicate it with different parameters?
No, so like the whole premise in here is that you have a singular part, which is this one, but the singular part, just because of the different like the fact that you can parameterize it with those equations, you technically have all files in the same part. So then if the boss comes, just give them this part. You're like, all right, you modify the parameters. And you can create anyone you want. Well, eventually, if you wanted to.
So I replicate, like if I want to have 2 screws now, how do I like replicate them?
No, now if you wanted to have 2 screws, what I would do is create one with your set of parameters, create another one with your set of parameters, just save them. Save them as.
You do like, yeah, save as, it'll make another file.
Oh,
So this is the story of not like kind of, but not really, like having all screws at the same time, but as a singular part. Any questions?
that's a part of computer weave.
Okay, this is fairly simple for now, and you can have fun now. We're done with this one. Let's do this. This one now, yes, you will try it out. Let me do a 10-minute demo for this one, and then you guys go and you can try it out. Perhaps what I'll start by doing is I'll save this first, and then I'll go here to File, New, Part. And I'm gonna bring this picture in here. So what things could you parameterize out of this chair?
Height.
Height,
The number of legs, maybe?
yes.
But
And I
like,
will
how
do-
many parameters, like how big the seat is, like how tall.
Well, height, I would say height and number. Yeah, we can keep it simple. And then there's one more
The
that
diameter of the chair itself.
diameter chair. That's it. It's super easy like that. So let's do a quick version of this thing. I'm gonna go here to equations, that little tab right there. And we can just start from before we do anything by creating the equations. So I'm gonna call this one diameter. Diameter. And sure, 3 inches, why not? Even though that's too small, it's a toy chair. Then we can call this one height. And the nice thing is that you can always edit these things later. And we can create one which is n legs. And then we can call, in here where it says inches, I can go velocity, area, force, pressure, unit less. There we go.
How did we bring up this tab?
Oh, sorry.
How did we bring?
Oh, I just click in the unit.
Oh, okay.
And you can change it. I just want to do unitless because now I'm gonna make that 5.
So this is equations.
These are equations, yes. And now we're gonna click on done. All right, you have them available to you. So let's make a quick chair. I'll go here to sketch. I'll go here to plane. Maybe what I'll start by doing is I'll build it from the seat itself first, and then from we can come down. So we'll go here, and I click on D to define the space, and that can be right there. Okay, and then we go here to 3D model, extrude. We can say 0.5, so we can always have this as fixed, and then we can modify the height as we go. Okay, and then I'm gonna do, then we can add fillets and all of the good stuff later. I'm gonna go here to circle. Let's make that 0.5. And I'm gonna extrude that. How much height did we say did we give it just a second ago? 0.5 was it? Okay. So what I'm gonna do here is I'm gonna make this be equal to height times 0.3. It's funny. You will see why this will make sense in a little bit. Then I'm gonna click in here. I'm gonna do yet another circle. And that one, let's make it 0.65. 3D model, extrude, and we're gonna make that one also 0.3 in there. Then actually I'm thinking for a second. Yeah, let's keep it simple like that. And then if we go back to our picture, you see that that's where the legs are starting to come off from. Okay, so to do one of those legs, we can use a sweep. So a way to do that is we go to origin and we select one of these planes. We go here to sketch, and we can go here to our friend the spline and say, actually I may end up changing that one later, but maybe that's fine. And then I might, let's see, actually no, the spline might be a problem later in the future. So you know what, I'm gonna do an arch instead. leave this like that. Okay, and I'm gonna use a bunch of lines, construction lines, to make sure that the overall height of this thing is fully defined. Let me make this perpendicular here. You see how I'm like purposely digging it a little bit to the inside, that way I'll make a, oh, maybe what I'm gonna do is, where's the origin? Oh my goodness. I'm trying to find, okay, we're gonna project geometry, that line, that way we can do a little cross-reference from here. There we go. Oh, I need to make them parallel too. This will make sense in just a moment. Let's make that 0.15. Here, the problem is that this is where you have to be extra cautious about defining all of your dimensions. So if that's 0.5, that's 3.3 height, that's 0.3 height, this means that we could technically make the distance between here and like there also 0.3 height, and then leave for the wheels 0.1 height. Does that make sense? There, that way it all scales like parametrically. The only problem is that there's a little bit of an overlap here, which I may change. Actually, I'm gonna do a project geometry. By the way, when you guys design your chairs, you can do it in whichever way you want. It doesn't matter. Oh, I do not want that. Maybe let me make those two coincident. There we go. And there we go. Okay, so now that's tangent. I'm gonna go to D, and let's make that.
What was the last to turn the arc from being?
Oh, so
Yeah.
it was like that, and that's a line that I project. So I'm clicking these two at the same time. Tangent.
Oh, okay.
That way it's just all, yeah, the same stuff. One moment, we're gonna, there we go. Okay, final step, we are gonna make that height times 0.25 this time. Okay, it's all, actually, not all of this is black because we need to define like how big do we want that diameter to be. So if that's dia, we can say that I want the distance from here to there to be diameter times 1. Actually, times 0.75. Let's see what happens. Okay. So the more dimensions that we can reference with respect to like those three parameters that we created, the better. And everything else will be smooth sailing from there. And maybe one last thing that we could do. There we go. I'm just gonna create one more line. It's gonna go like that. We're gonna change that to, and we're gonna make that 0.05.
That's supposed to be height. Oh, that's.
No, that is just like a little trick that we're gonna use in a minute. And I'm gonna click on finish. Okay, I promise it's gonna be super easy from here. What we're gonna do is go here to plane, normal to curve at some point. I'm gonna click that line, that way we have a plane there. And then what we can do is do a sketch over here, and we can do a circle. And we can make this circle be, what's your favorite number? Within reasonable dimensions. Point, I'll give you a hint, point something.
Well, I know it's point something.
Oh.
Seven.
Excellent. It doesn't.
That's too big.
That's too big.
Then let's do this 0.5. Okay, the 0.5 is fine. But now the moment of truth is first, why isn't, okay, I think that's fully defined. So go here to 3D model, then sweep, and sweep, will you give us the pleasure? No, why not? Because I can tell you why. This is not fully rounded. what we can do instead is go here to finish. So this is an example of where sweep wouldn't work. So I'm gonna just edit this sketch again. And maybe this is where we might need to strategize. Do we want to, you see that
Sweep again?
sweep is one where you have like a line and a profile and zzz, it goes like that.
Do we need the edge to be smooth?
Yes, I think we could do that if we go here to fit it and I click in. Yeah, but it's not,
Can you fill it?
Right?
yes. I think what we can do is I'm gonna make
Pause.
this into a construction line and instead construction, what we can do is just an arch that will go like this. Oh, hello, hello. And what we could define is, I know this is very convoluted, all of this stuff. We're gonna make that like that. Okay. And let me just make another line that will go like this. I will make this line and that line be tangent. Like that. And I will make this line and that line be tangent.
Okay, that will work.
Yes, it appeared out of nowhere. However, believe me, this is, I know this is dark magic in here. When we go back to edit the sketch, I'm gonna get rid of that circle. What we can do is go here to project geometry. That point, there we go. Now I'm gonna do circle from here. And we're gonna make this 0.5. Okay, moment of truth. 3D model, sweep. I'm not sure. Let's see. Let me see if I change the settings.
Reselecting that, right?
I think so.
You made the circle smaller, and it might be.
Yes, that is possible, but where's the fun in that? Making it like smaller. I wonder. Let's try that one for a second. Let's see whether the 0.3. So here to sweep again. I wonder whether if I could just, if now we can just simplify our lives and make this curve just a little bit easier from here. You know what? Let me just delete the sketch from here and time to do something kind of complicated. I'm gonna create a plane right there. And I'll do a sketch in that plane. And we're gonna do a circle. It's gonna go like that. Let's make that 1.5. And now let's see whether it would want to do the sweep now. I might need to edit some of the curves later. Okay, I know what I do. Sketch 4, edit. Let me just make that a construction line. Finish. Okay, good. We're not done, but this is partly what we wanted.
Is it too big?
No, but now you can start to see where the problem was. This is our original plane, right? And we wanted to do a sweep that started here. You see how this one, it's like chopping a little bit in the inside of that one.
Yeah.
Does that make sense?
Yeah, that does.
What we would need to do instead is draw a plane that we can do an offset plane from that one by 0.5. I know we are kind of deviating a little bit from the height parameters that we were establishing earlier. It's okay. But now we can go here, do a sketch. And I'm gonna go back here. By the way, when you guys do this, you can just make it way simpler than what I'm doing. But this is more for completeness. Okay, I think I brought the correct point. I'm gonna do a little line. 0.5. And what can we do to connect a circle and that circle like this?
A loft.
Yes. It's a little bit of reviewing pretty much all that we've done this year. So 3D model, we're gonna go here to loft. Select that.
It works.
Does it look nice? Not really, but it's all right. Like I mean,
What if you do project geometry for like
actually,
the
that is
circle?
that is not a bad idea. I like it when the students are better than the
Why do you
teacher.
do like 15?
We could also feel it better, but I'm gonna try this one. I think it's an even better suggestion. Even though it's an oval, but that's fine. It's not the end of the world. But now we go here, go to finish. Okay. It's not bad. Like it's this is okay. But now the key point of our story is that we go to our friend's circular pattern, and all of this work won't go in vain because select features, I select that, and I select that, and then for direction I'll select that cylinder, and then instead of 6, I will say what was it? N legs. Okay.
Also, that's the equation.
This looks scary, place.
By the way, I don't want to do that yet because we have to design the wheels. So I'm gonna first hide this stuff. And then for the wheels, I promise we will keep our life simple. We're gonna do a sketch in here, edit sketch. And we're gonna project geometry, this stuff in there. So now approximately up to there, it was a 0.25 height, which means that we have about 0.15 height left in this space. So what can we do? A little, oh, I have an idea of something. How realistic do you guys want this to be?
Really realistic.
Really realistic? Okay, if you say really realistic, it's fine. I'm not gonna, there's not, what?
It's the idea.
No, it's okay. You guys, the public has spoken. I'm not gonna change this. Let's make that 0.15 times height. And let's make this 0.12 times height. Okay. And what I'll do is the following thing. I'm gonna go here to model, extrude. We're gonna make it symmetric, and we're gonna extrude by 0.2. Okay, I think that's decent. I'll go here to fine. You see that that's floating in there. That normally you shouldn't do that, but it's okay. I'll do here a sketch on that face. And what we're gonna do is the following thing. We are gonna go here to project geometry, that line. So that brings us here. And I'm gonna draw a little bracket that goes like that. We can make this guy and that guy equal. We can define this distance from here to there to be, I guess, 0.8 times height. Oh,
Whoa.
oh, 0.0. No, that's too little. Yeah, we could do 0.12. Okay, that's decent. And we can say that we want that distance, this one to be 0.2. Fine. 3D model, extrude. I know it's not gonna look that nice yet, but believe me, we're gonna make it look nice. So we're gonna leave that in there, just like that, and we're gonna do another sketch on, well, plane. And we
Can
can,
you just like copy it and paste it on the other side?
yes. So I created a plane between those two faces, so we do a little mirror. Or actually, before I do that mirror, let me do a sketch on this face in there. And what we're gonna do, and I'm thinking strategically about the order of operations, right? So I'll do a fillet first on these two sides. 0.1. Okay, that way it looks like the bracket in there. Now sketch on this face. And we're gonna project geometry that and that. Then 3D model extrude. We're gonna say through.
Oh, that's good.
So it looks smooth. And now that could look even better, so we can do a little fillet of sorts in there. Smooth, right? Smooth. That's what I wanted to do. So we're gonna leave that like that. Actually, if I could go back in time, I would have made the wheels even nicer. I could have done a fillet to the wheels. In fact, oh
You can't do it now, right?
no, now after the fact, what I hate the most about Inventor is the fact that I cannot move things on the feature tree in time. So it's okay, like this wheel is gonna look a little bit sad, but we're gonna do a mirror now of what were the features? What, extrusion 5, fillet 1, 2, 3, mirror plane, that. Okay.
Wow.
So now you got a wheel of our chair. We're almost done, I promise. Let's that plane is that one. We're gonna hide the visibility. So now here's what we'll do. We'll go here to circular pattern, select features. Oh, is it like all of these guys? Select direction that, and now in legs. Ta-da! And actually, that looks kind of awful in there, like that little gap. But if you look at the picture of this thing, it has like a little tube in
Knob.
there. So what we can do is project geometry that, and then we can go here to 3D model and extrude that by I times 0.1. Okay, let's beautify this thing. Now, what do I mean by that? Adding a bunch of chamfers all around this place. 0.05. Just like that. And then we're gonna add a chamfer here, another chamfer there. Let's leave it as a stool. How about that? Or do you want to add the little chair behind it? It's okay.
How do you add the little chair? Yeah. You
I
drop.
didn't know. Let's add a little chair behind it. We'll do a sketch in here. And what we can do is,
Question.
yes.
Since I'm still on, what does the project do again?
Oh, the project is like saying, say I had like a plane that is at this angle, and I'm working at, so I drew a sketch at this angle, and I have another plane in here. So if I do a project geometry, it's gonna project what it sees here on that plane. It's literally what it math. I know math is dangerous, but so let's go. Let me just do the chair just to finish this stuff. But I'm sure you guys want to do this now. I'm gonna do a little arch in here like that. It's gonna go. Is that the? Let me just. Yes, I guess I could modify that to always be diameter there times 0.8. That's too little. Actually, that might work. Wanna make that a construction. Then we go here to our friend offset. This one, okay, there we go. Now offset that one. It's okay. Well, that doesn't matter. Let's make that distance 0.2 as an example, right? And then I'm gonna go here to line. I'm gonna join those two. I'm gonna bring this up by say 0.25. Now I know that looks ugly, so what do we do? Well, let's find that plane, sketch, and what we can do is go here to arch. Maybe. Just trying to find the middle of. Oh, I have to. Let me go do a project geometry of those two. There we go. Let me make. Just like that. Let me just define the distance between here and here to be 0.2. And as a final act, what we're gonna do, like sorry, I'm gonna add a little bit more distance on both sides. I'm gonna make those two. Sorry. That and that, let's make it equal. Almost done, I promise. Let's make that diameter 0.1. And then I do a big fat circle that we're gonna put in there. That's it. So what do we have from here? Then just draw a box around this stuff. And maybe you're starting to guess what's gonna happen in just a second. This is that idea of shaving stuff out. What do I mean? This might give us an error, but extrude, cut. But we're gonna go on that direction and all the way through. So now you have like a smoother looking side, and let's beautify it with a big fillet in there, 0.5. I mean, it's already a complex looking thing, and it didn't take like a lot of commands to get here. Oh, that's too much. Okay, let's see. No, cancel. Okay, let's do it at 0.50. Oh, I think I might need to do them individually on each side. So let me make that 1.6. Okay, 0.5. Let's make it on that side too. Fascinating how on one side it doesn't let me, but on the other one it does. It's possibly uneven, that's what it means, but now, moment of truth, like this chair for me, it's meaningless unless what? I can edit the parameters, right? So let's go ahead and do that. So save. So go to equations and look at how this quickly populated. These are all of the different dimensions defined. So you go here to diameter. So let's modify this one. Let's see whether it would work. So click on update. Sorry. Okay, there's already an error from that one, so I might need to look at that one. So let me bring it back at 3. Now let's do number of legs. Let's do 7. At least the legs is working. And what about the height? Let's do this 5. So the height works. And I can tell you that right away, the reason why I'm gonna get rid of that. Let me delete that. The reason why the diameter didn't work is because of that. So let me go here to diameter. So it's nice because now the diameter also controls the bottom part of the chair. It looks like a freaking spider, and I hate that.
Yeah, the 8 legs, that'll really be.
Give it 8.
Mm.
You decrease the height.
Oh, disgusting. But actually, let's play around with this stuff, right? Like, oh, sorry, need to change that to 3. All right, so 3 seems to be the limit of where this starts to fail. Let's do 3.5. Let's see. So there's limits to how good you do it, but kind of nice, right? All of this stuff.
Yeah.
Go and try it. let's do the last thing, which is, ta-da!
What is this?
We are gonna make an
Oh,
airplane
I've seen this.
fuselage, just the fuselage part.
I've been very excited about the airplane thing.
Yes, I mean it is an aeroastro like workshop, so there has to be some, besides the X-wing fighter, some vehicle that flies. Given what we've learned today, what are some things that you could modify? Suppose you are Boeing, and they tell you, Mr. Boeing, Mr. Engineer, like I do, or Mr. Engineer, or whomever it is, I want you to design 5 different planes. And you go, oh, design that is super difficult. Let me design one, and let me modify some parameters to make a family of aircraft. Which ones would be those parameters that you would change?
Like the ratio of the window to the diameter.
Actually, that's not one that I was thinking about, but like, yes, that could be interesting.
How many seats inside? Like the
Yeah,
diameter of the entire thing.
diameter, yes. So let's save diameter. That's the one I wanted, one of the ones. We're gonna do a simplified version, by the way. It's not gonna be that difficult. Diameter is one.
Number of windows.
Number of windows is another one. And one more, actually, I will do, which
Like
is
the, like,
well, it could be the length, and we can measure the length in terms of number of exits.
yeah.
All right, let's do this. This should be the version that we're gonna do right now. It will be very easy, but it's just to illustrate another application of parameters. So here, apart. So I'll start right off by creating a few parameters. We're gonna call it diameter. I'll change those numbers later. We're gonna call this one in windows, and we're gonna call this one n exits. Today, folks, you are airplane designers. And these two, because they are n, we're gonna make them unitless. Back in the day, I wanted to be an airplane designer too, but I realized I like more other stuff. Let's start easy by making 2 exits, 10 windows between the 2 exits, and a diameter of does it 1 inch? I mean, it's not that it matters, but and we'll do a sketch in here in the XY plane, and we start by doing a quick circle like this. I'm gonna do D. We're gonna make that diameter. And then we'll do this one that's called offset. And we're gonna do like a little like shell to this wing. So we're gonna call this maybe diameter times 0.05. Oh, that's actually too much. Okay, I think that's decent in the air. And then another thing that we can do is like the level where the passengers would sit.
Isn't it supposed to be more of a instead of circle? And
Yes, true. But I think the fuselage part, if you're just a fuselage designer, you could approximate it as a tube. I mean, if you look at this picture in here, it looks mostly like a tube, even though it's more like an oval. You're right. That's why I'm not an airplane designer. I'm just make CAD that is an approximate depiction of reality. And we're gonna make this diameter times, let's see, 0.1. So this is where the cargo will go, and this is where the passengers will go. I think this is a decent approximation. Oh, wait, let me do another line. I will go like that, and we're gonna make this height be as well diameter times 0.01. That way it's all the same height. Now we go here to 3D model, extrude, and we're gonna extrude like that. So it's very, very simple. Now the question is, by how much do we extrude? So we're gonna do the following math. We're going to assume that, actually, we might come back to this number in a minute, but we're going to assume that every little window, like the distance, like you can think of windows as little modules. So every little window can be 0.1. So let me, do you think you could, yeah, you could fit a window there, right? Like maybe we could 0.08 is one window width. So we're gonna say times number windows. Okay. So that's how many we're gonna fit. And then we can say that every door would be, so I'm gonna control X. Let me see 0.05. How would that look like? Okay, maybe 0.25. I mean, every door is 0.25. We'll do this plus 0.25 times n exits. Exits. Good. I'm speaking Chinese right now. I know with all of this math, but believe me, all of this is gonna make sense because all I'm gonna do now is go here to origin, then to that plane, and we're gonna do an offset plane from here by. Well, that doesn't matter. I don't even. Oof, that actually does matter. Edit dimension. We're gonna make that too. Okay. And we're gonna do a sketch in this phase. And all I want to know is I'm gonna project geometries that. So what does it bring is those two lines, and I want to project geometry that line, that little point in here. So now all I know is that we're gonna start drawing stuff in this area right here. So what are we gonna do? First thing is I'm gonna segment this area like this. So what did we say? We said that the distance between here and here, that's a door, that's 0.25. And then we said that the distance from here to here, that's a window, and that's 0.08. I claim that we're gonna do a singular window and a singular door, and that's gonna be enough. Why? Let me just convert these into construction, just like that. Folks, we're just gonna do a very simple rectangle in here. We might change the size of this thing. Don't worry. And we're gonna do another rectangle approximately here. Big windows, right? We like big windows on airplanes. That way you're not as depressed. And we're gonna say that that's gonna be 0.01. So these are dimensions that will always be fixed. 0.01. D 0.01. And we can say that we can always come back, by the way, to these numbers. They're not fixed in place. Point. And then we're gonna fill it, this stuff, in a little bit. 0.01. Okay, and we're gonna make the height of this guy be, well, let's make it a function of the diameter as well. So diameter times 0.1. How big would, that's 0.1. Okay, I think that's fine. And let's make the door be diameter times 0.4. Okay, that's decent. I'll click on finish. So we have that sketch. I'm going to introduce the last command that we'll learn this year. It's called wrap, which is how you make the Diet Coke. So what does this do? Well, we go here to, well, it's called emboss, wrap, it's in SolidWorks. So for profile, I will select that rectangle. And I'm gonna say that I want to extrude like that. And let's see what it does for a second. I'm gonna click OK.
So it just cuts through.
Well, it's not quite a cut through. It's as if it's doing a projection of the thing in the cylinder.
But actually, the actual length is longer than your rectangle.
Yes.
Okay.
So this depended on us projecting this in the first place.
Yes. So it's as if you're projecting the rectangle. It's wrapping around. Does that make sense? I could have drawn like something that was way longer and it's wrapping around in here. Now, the reason why this is cool is because then, you know what, I'm gonna go here. So we are, by the way, what you're noticing is that we're designing part of the fuselage in here, 0.02. Like you would need to do the doors, you would need to do a lot of things, which we're not gonna do. But we're gonna leave
Is
that.
this the same as filleting it when it's 2D and then
Yeah.
wrap it?
I just like to fillet it like that. And I'm gonna show that sketch again. Visibility. Let's do it again. Emboss, profile now with that guy. And do okay. Oi!
Composition.
Edit feature. I need to do that one. Now, yes, we're gonna hide this stuff. We're gonna.
Is there a selection or like a feature that just draws it on the thing without cutting or?
Oh, without cutting, you just want to. Yes, instead of point one. Great question. But let me just finish this window for a second, and I'm gonna get back to you. Oh no! Hold on. I hate it whenever I select the wrong edge because
Because you have to choose everything again.
we have to choose everything again. So we know the windows are always fixed in size, and so is the door. I mean, proportion-wise, it looks good. And I'm gonna hide this stuff in here. What I could have done instead is, if we go back to the original emboss, I'm gonna go here to edit feature. I could have said 0.01. Actually, that's still too much. Edit feature. Do you prefer like this or?
No, I was just asking, like, what if I wanna do something like this, but.
It's just changing that number, but we'll leave it like that. Let's finish this. What we're gonna do is a rectangular pattern. Select features. I just want emboss 2 and it's fillet. Select direction is gonna be that. Then we're gonna change it. Now, what did we say in Windows? And what did we say the distance was gonna be? 0.08?
Wait, what did we do again?
Oh, a rectangular pattern.
Oh,
And I click on OK.
But
And
when we're doing emboss, if we increase the depth, it's just gonna go through the other edge.
if it's very deep, I guess so. And then here with the plane, I'm gonna do a plane that is gonna go that face and that face. Why? Well, we're gonna mirror
The door.
features the door. Now, what am I realizing is that I kind of don't like how big the door is, so I might edit that in a second. So what do we do? Visibility. I'll go here to
Emboss.
first, yes, I will go here to edit, and I'm gonna make that 0.02 instead. No, that one is fine. 0.02. And I will change that one as well. 0.02. Okay, that looks a little bit smoother. In there, maybe you might want to change this a little bit more. What else can we do? Let's mirror it to the other side. So now let's go here to mirror. So features, I'm not sure which, we have to pretty much all of them. Mirror plane. Actually, I have an even better idea than that. Oh, I'm gonna delete that sketch. I'm gonna do a sketch on this face. And I'm gonna do a project geometry of this. Like that. So it brings everything. It doesn't matter. But I'm gonna do a big actually, it doesn't matter. I can just do a massive rectangle like that. Because I'm gonna go to 3D model and extrude everything on the other side. I know this is weird, what I've just done, but
You can mirror this now.
I can mirror that part. However, before we mirror it, let's do a couple of things.
why did it just mirror it the same way we mirrored the windows of the door?
I think based on experience, this wrap command, this emboss command complains with the mirror. Fuselage parametric fuselage, let me call it parametric fuselage. To say. One parameter that I wanted to, so you know how we have the number of exits parameter? So that in essence is gonna be making a linear pattern of this stuff. So how do we do that is we go here to rectangular pattern, but I wanna do a pattern of bodies of the entirety of this thing. And then number, I'm gonna say n exits. And now the distance is gonna be the fun part, where we said that that was gonna be 0.08 times n windows plus 0.25. I think that should be fine. And I'm gonna click yes.
Do you need a time store or no?
No, I might need to come back to, I might need to modify something later. But then for direction, I'll select that. I'll click on OK. Then I will have two of these. Now, one thing that I will change is in this guy, edit feature, instead of times n exits, I'm just gonna do times 2. This will make sense in a minute. Now, last thing, let me just save. I'm gonna do a mirror of bodies. Mirror plane is gonna be this stuff. Okay, good. Are we ready to modify parameters? Yes. All right. And so I go here to FX. Give me parameters.
5 windows.
Sure, 5 windows only. Okay.
Or like 25 windows?
Let's do 5 first, and then diameter you wanna leave
Is
it at.
that per part or for the entire thing?
We'll see what it does.
I think diameter is like,
Do you want it the same? Do you want it bigger, the diameter? Do you want it smaller?
Small.
How much smaller?
How much smaller? It's already only an inch.
Yes, it's a small plane. It's a model plane.
Make it 0.5.
0.5, okay. And how about number of exits? Let's do 4. Update.
that does not look good.
No, well, why?
They have to
Because
stand
it's like
up to see
the,
windows.
it's like the, let me just go back to,
Doesn't have 5 exits?
let me go edit this stuff in here.
There's an extra X.
What I think we didn't, this parameter in here. Why is that 0.2? Is my, oh, because,
It's just not relative to the.
yeah, to the, that is exactly right. So we should say diameter times 0.1. No, that's too little. Okay, I think that's fine. Yeah. This is where you have to get creative with how you do it. But if we were to, let me just say, if you were to go here to FX and we make 25 windows, we bring it back to 1, which we know was kind of all right, and we leave it at 4. Now you got like a massive plane in there. I wouldn't say this is beautiful, but it starts to illustrate the sort of things that you can do. You can go and try it. Or maybe what I can say in video is that this is where I'll end the video. It was a pleasure, and stay tuned for more how to CAD later in the year.